Hey guys! Welcome back to my channel. In this video you will learn about what is titration and how to perform titration. But before that we make sure to subscribe to our channel and turn the notification on, so you don't miss any videos in the future. Titration is a procedure in which a known concentration solution is introduced to an unknown concentration solution until they react in an equal mole amount. Titration makes use of equipment that delivers highly precise quantities of solutions. If you know the exact volume of both reactants and one of their concentrations, you can compute the concentration of the second reactant. Titration is the technique of correctly measuring volumes. Titrations necessitate the use of specialized equipment. A burette and a pipette. Burettes and pipettes distribute highly exact volumes of solution, increasing the analytical technique's accuracy. A burette is a graduated glass cylinder that delivers precise volumes of a standard solution. A brute accurately distributes a precise volume of standard solution titrant into the conical flask. Using the stopcock, the solution is dispensed gently. To use a burette efficiently, you should keep three things in mind. The first step is to wash the burette. Rinse the burette with water, followed by the titrant. Hold the burette over the sink with the stopcock open while rinsing. Wash the sides of the burette with water using a wash bottle. Water should flow through the burette and down the drain. Attach the burette to a retort stand and set a waste beaker underneath to catch any waste titrant while rinsing with the titrant. The majority of chemicals have risks associated with them. As a result, never assume that a chemical can be washed down the drain. With the stopcock open, pour part of the titrant into the burette, washing down the sides and any water droplets left over from the previous wash. If there is water in the burette, it will lower the concentration of the standard solution. Step 2. After washing, fill the burette. Keep the waste beaker underneath the burette and keep the stopcock open. To begin filling the burette, use the same funnel. The titrant will begin to wash through the membrane into the waste beaker. This is done on purpose to prevent bubbles from forming at the burette's tips. Remove any bubbles that form before beginning the experiment. If the bubble washes into the conical flask during the titration, the volume will be recorded as higher than it is. Step 3. Parallax mistake should be avoided. Read the burette at eye level at all times. Show how the volume changes as you look at the meniscus from three distinct angles: above, at eye level, and below. A pipette is a glass tube that dispenses precise volumes. A pipette is used in titration to measure and dispense an unknown concentration solution into a volumetric flask. The following points will help you to use a pipette effectively. First step. The pipette should be washed. Before measuring a sample, like with the burette, the pipette must be washed with water and then with a titrant. Place the pipette's bulb on top and suck water into the pipette from a beaker of water. When the pipette has been filled all the way to the designated line, fill a sink or waste beaker halfway with water. Fill the pipette with titrant and place it in a clean beaker. Never place a pipette at a flask containing an unknown concentration of a solution because an unclean pipette will contaminate the solution. Place the chemical in a garbage beaker. Fill the burette with the titrant again and pour it into the conical flask. This is the sample or analyte. Step 2. Keep the last drop of solution in the pipette tip. There will be a drop left at the tip of the pipette after you have dispensed the solution into the conical flask. The volume of the pipette has been adjusted to account for this decline. If the drop is forced through, the aliquot volume will be larger than intended. Step 3. Parallax mistake should be avoided. Examine the meniscus at eye level. If you look at it from too high or too low, the meniscus will not be in line. The general procedure for performing a titration is as follows. The standard solution is first poured into the burette. This is referred to as the titrant. Titrant is the standard solution in a burette that is introduced to an unknown concentration solution. When a certain amount of solution is dispensed from the burette, it is known as titer. The volume of standard solution dispensed from a burette is defined as the titer. Attach the burette to a retort stand using a clamp. To balance the weight, make sure the stand's base is on the same side as the burette. Transfer a volume or aliquot with a pipette. A fixed volume of liquid measured via aliquot is referred to as an aliquot. Use a pipette to transfer a aliquot of the solution with unknown concentration into a conical flask. This is known as the titrant or analyte. Titrant is a solution whose concentration is determined through titration. Analyte is a solution with an unknown concentration. Include an indicator that will change color at the reaction's equivalence point. Take note of the burette's initial volume. Turn the burette's stopcock or tap to begin dispensing the titrant into the unknown solution. This should start to generate a color change, which should vanish after a few minutes of stirring. Constantly stir the conical flask to ensure that the reaction is uniformly spread across the flask. Continue to add the titrant until the color becomes more difficult to remove by stirring. At this stage, adjust the stopcock so that just one drop is dispensed at a time. When a persistent color change is seen, turn off the stopcock. This is the conclusion. In the burette, record the ultimate volume. To calculate the total amount of standard solution dispensed from the burette, subtract the initial volume from the final volume. This is the subtitle. You can repeat the procedure until you get 3 concordant titers. From lowest to highest, concordant titers varied by 0.1 milliliter. To be used in calculations, these concordant titers must be averaged. This improves the accuracy of the results. Lesson for today. I hope you have learned something new today with us. Thank you for watching my video.